Chapter 8, Number 34. Catching a wave, a 77 kilogram surfer starts with a speed of 1.3 meters per second, drops through a height of 1.65 meters, and ends with a speed of 8.2 meters per second. How much non-conservative work is done on the surfer? So we have something like this, where there's the wave, and here's our surfer, falling through a height h, having some initial velocity v0 and some final velocity vf. And what we know is that the work done by non-conservative forces is the change in the total energy. So the work done by non-conservative forces is the final kinetic energy plus the final potential energy minus the initial kinetic energy plus the initial potential energy. If we take this to be our 0 point, then we end up with 1/2 mvf squared plus 0 minus 1/2 mv0 squared plus mgh. So we have 1/2 times the 77 kilograms times the final speed, which is 8.2 meters, and then all squared. And we subtract 1/2 times 77 kilograms times 1.3 meters per second, all squared. And then we subtract off the gravitational potential energy that's been lost here. And we end up with, this turns out to be 1277.3 joules, which with the only two sig figs that we have, turns out to be 1300 joules of non-conservative work. And it's positive, which is actually a little surprising to me, but this means the wave must have carried the person forward and downward as well as, instead of retarding it, which was my instinct. But it works out. The speed, if there had been no wave at all, would have been only 5.8 meters per second. So clearly we have picked up some work from the water.